Hi, welcome back to the last round of presentations, and please welcome Professor Dr. Dirk Slama, VP Ecosystems, Robert Bosch.
Thank you. Good afternoon. We have half an hour. I've prepared a little journey for you. Before we get started, please, quick show of hands. Who's making his money by using Microsoft Visual Studio? Who's coding or doing AI stuff? Okay. Who is making his money by using Excel? Okay. Who's making his money by using PowerPoint? Okay, what are the others doing? Okay, I want to talk a little bit about digital first and put some light behind this. So let's start by taking a walk back down memory lane. Who has been using this website about 20 years ago? Who has been using this website? Over there. I think the first time I've used Amazon, it already looked like this, if you remember. Yeah. So the thing to be said about these digital-first internet pioneers is that they are constantly innovating. They have, in fact, actually perfected the methodology how to innovate. So they have introduced things like design thinking, like lean startup, heavily based on early experimentation, on incorporating customer feedback, and everyday improving products. This is, unfortunately, it's in German, but I think it still proves the point. This is actually 3 screenshots from a single day where Amazon was giving pretty much the same dialogue, just changing the little button down here. So useful, or happy face, okay? Trying to figure out which button is more likely to be pressed by customers, right? Like super small detail in the Amazon jungle, so to say, yeah? But really focusing on improving their products every day using this approach. So if we try to apply this to automotive, we have a tiny little problem here. In automotive, it really depends what you're doing. If you are making your living by bringing Angry Birds into the car, you have no problem. If you make your living by bringing airbags into the car, right, that's a first time right type of thing. It's an entirely different story, okay? But digital innovation, like take this airbag example, right? We see this every day, the innovators, they now use in-vehicle cameras to do things like, for example, you're sitting, you put your backpack next to you, and then the car complains because it thinks a person's sitting there which is not using the seatbelt. Okay, so now they're using AI to basically detect whether a person is sitting there or actually, not. And it's these small improvements that make better cars, and where we have to decide on an everyday basis, is this improvement basically in the area of Angry Birds or airbags, yeah, ASIL or QM. And that's challenging because everybody in this room who is technical knows this, right? The Kahn matrix, right? So I want to do a tiny change and I have to talk to a gazillion people, and they're not even inside my own organization. So that's a nightmare, and that's slowing us down. And then the other thing is, I don't know if you can recognize this picture. This is literally hell, okay? This is what I would call the integration hell. Okay, so basically you go on, you do some coding, and your suppliers are doing some coding, and you think it's going pretty well, and then you start integrating, right? And 3 years later, you're not done integrating. Okay, so that's another big problem that we're facing as OEMs. And then really this clash of two worlds. So I'm a software guy through and through. I spent 20 years with startups doing software, and the last startup we had was acquired by Bosch, and then after a year with Bosch, I developed this theory. Bosch has about, 420,000 people. I think every Bosch employee has a secret tattoo on the forearm, and there's 2 different kinds of tattoos. There's either start of production or minimal viable product. You can't have them both, right? And the challenge really is, how do you bring this together? How do you bring these different cultures together? I swear, half of the previous presentation had the agile infinity loop, like, yeah, let's all be more agile, but this is hard in automotive, right? So how do we do this? How do we actually cut the Gordian knot? Well, it's actually very easy. It has nothing to do with eating better, although that helps, right? But this is very much about decoupling. This concept of the bento box in Japan, where you have this neat layout that you use to basically group similar types of food together, yeah, in different compartments where they belong, right? Creating a clean code architecture, right? And I would argue, I mean, there is no clean code architecture, or you're doing something wrong from a business point of view, but at least there are cleaner code bases, right? So if we look at what can we learn from the internet guys. So this is the combined technical wisdom of 25 years internet, right? So what did they do, right? Well, DevOps culture. Okay, so remember those days when I had this 20 years ago working for a large German airline in the development side, and whoa, we did funky stuff, and we decided to use a NoSQL database, and we were so proud. And a year later, for the first time, we talked to the operations people and said, hey, this is cool, operate this for us. And they basically said, nah, guys, we can only operate Oracle. Go home, come back when you have fixed this, right? So that was a long time ago, and DevOps kind of has repaired this. And obviously, continuous delivery. We had the presentation from Roland Berger earlier on, and he was emphasizing that obviously we need to automate our delivery pipelines. Yeah, so high level of automation is key. And then loose coupling or disentanglement. So microservices, APIs, and containerization. The internet today runs on containers. And actually, one last thing, which I think is also really important, chaos monkeys. This was actually introduced by Netflix when they migrated their architecture to AWS, and they figured, wow, we have a hugely complex distributed system at hand here, and we can't manage the complexity of this by just trying to define the state of the system as a whole. Yeah, this would be as if you were trying to fix the internet. Right? So they basically said, okay, we need to have a loosely coupled system, and every engineer in our organization needs to be prepared to deal with the failure of the other folks. The other developers are stupid. You are smart, the other developers are stupid, but your code has to be prepared to deal with the stupidness of the other developers or somebody just plugging a cable or whatever. Okay? So make your own code, make your own components reliable, okay, and test this by actually introducing, chaotic system testing. Okay, so this is very un-German. We Germans, we like to plan stuff, right? So this is the anti-German way of testing. And then, of course, what we also have is not only the internet folks, but it's the smartphone folks. Who is a fan of Big Bang Theory? Okay, some of you. So you might remember the episode when Sheldon Cooper had this app, and he was really annoying. He was running around, and whenever something did something stupid, he did this noise with an app, right? So the whip splash sound. The developer of this app, did he know anything about Apple smartphone hardware? No. Did he know anything about how an accelerator sensor in a smartphone actually works? No. Did he know anything, how to do sound programming to actually create the sound? No. All he wanted to do was 2 lines of code. If smartphone moves, then make a splash sound. Okay? And this is what the smartphone guys have perfected. Okay? Putting in hardware abstraction layers, putting in APIs, putting in delivery pipelines, app stores, and so on. And this is where we're just starting in automotive. So again, in the Roland Berger presentation, we heard that in 2030, even in Germany, we might arrive at these centralized EE architectures and so on. But maybe we can start, as we've also learned, halfway. So let's look at vehicle APIs. This is a set of vehicle APIs coming from an organization called Covisa. And the basic idea here is if I have a vehicle API, like an API to open a door, okay, then I have these two sites, MVP, SOP. I can have basically the hardware-centric people deliver this API to me, and then I can take somebody who is a developer fresh out of university who has never heard of Khan, Lin, or FlexRay, develop a cool application with it. Okay? So the basic idea really is, for example, here I have an API for a door, and I have, I don't know, Windows and child lock in it, and it reads like an iPhone API, right? Now, this kind of API I can use on the vehicle, okay? So we heard this earlier on, basically shifting functionality out of the deeply embedded layers and use maybe even container runtimes on board the vehicle, internet-style development in the car. And now I want to create a new service. So earlier on we were talking about Tesla. Tesla has this service at your house or even at your workplace. Okay, so let's say you want a service technician to have an app that he can basically open your door and repair your car for you or service your car. So what you need then here is an application running in the cloud combined with a smartphone that is calling a function on the car which is using this API. Vehicle, cabin, door, row 1, left is open. Okay? Now, another use case here might be a passenger welcome sequence. Okay? So our sales guys, they always want that customers can develop a more emotional relationship to their product, to the car, right? So I want the car to welcome me. Hello, Dirk. Adjust the seat according to my preferences. If it's a rental car, I don't know if you have this with rental cars. Last week, I had a rental car that was insisting to speak to me in Romanian. Now, I have no problem with Romanians, but I don't speak the language. And in order to tell the car to speak to me in another language, I had to tell the car in Romanian. That was pretty tough, right? So if that car would have, this welcome sequence, adjust the language, adjust the seat, and then actually open the door, I would have greatly welcomed this. So this type of algorithm can run alongside the service technician algorithm, okay? And it is also reusing the open door API here. Now, I don't know how many of you here are like serious automotive people, but those of you who are will now say, well, is that really a safe thing to have an open door API on a car? The answer is probably not, unless we make it safe, right? So in order to make it safe, what do I have to do? I have to, first of all, check that the vehicle is not moving, because I cannot open the door of a moving vehicle, okay? Then I need to check in my beautiful EE architecture with the rear camera that no motorbike is approaching the car when I'm opening the door. And then I have to check that there is, also with the side camera, no obstacle that I would bump into. Okay? And only then am I allowed to actually really open the door. Okay? So obviously there's a cost involved and there's a technical complexity here, and that actually brings me back to the chaos monkeys. Right? So I would argue when we have systems of a level of complexity of this, it's fine to have a solid test plan derived from requirements with the help of Gen AI, as we have learned, and so on. But I think you need to combine this with these modern test approaches. Now, let's come back to food. We were talking about building blocks earlier on. Okay, so we need to go from building blocks also to value streams, right? So how do we produce the food? How do we produce the software? How do we produce software where things are neatly arranged in the right compartments and so on, right? So we need work streams. We need to be able to decouple not only on the technical level, but also on the organizational level. We need decoupling, we need loose coupling, and we also need end-to-end organizations where people basically take on responsibility for a function that starts on the smartphone, goes over the cloud onto the SDV layer and then deep into the vehicle, right? So these people need to work together, but they need to be loosely coupled because they are working at different speeds, and they're also working with different safety and security parameters in mind and so on, right? So digital first really means two things in this context. It means shift north, right? Getting as much as possible out of the deeply embedded safety-related layers onto higher layers, and shift left, which means as much digital in the development process as possible. So shift north, yeah, coming back to this clash of cultures and to the distribution of software. And actually, again, coming back to the Roland Berger presentation from earlier on, that said, we need MBSE and we need agile. So anybody who has ever done MBSE will maybe agree that it's not entirely agile. And everybody who has done agile and code-centric will agree that, model-centric, planning-centric, how does this go together, right? Well, it goes together if we can introduce, on the technical level, this separation using a vehicle hardware abstraction layer, okay? And then there's obviously multiple shift norths here, right? So we have, first of all, in the EE architecture, as we have heard earlier on, the shift away from intelligent specialized ECUs towards centralized compute, so that's a shift on the hardware level. Then we have the shift out of the ASIL, the safety critical domains, onto non-safety critical domains, and maybe even from onboard to offboard. So that's the shift north. And then the other one, that's the biggie, the shift left. So what does shift left mean? Well, shift left means if you procrastinate, if you basically don't integrate and test early enough, you will end up in hell. Okay? Integration hell. And that's simply expensive, right? So the further downstream you detect integration problems, functional problems, and so on, the more expensive it is to fix them, right? So what do we need here? Shift left. So first of all, we need user experience validation and early stage prototyping. That's really important. Early on at lunch, we were talking about the poor souls who are caught every day in managing requirements and doors and Rhapsody and so many requirements, and we can't really map them to how we're delivering the requirements and so on. So this is why I strongly believe the Agile Manifesto says the truth is in the code. So start with prototypes, use web prototyping environments, and make sure that these web prototyping environments are already getting close to, for example, the vehicle APIs. And then the next thing, of course, is system validation utilizing simulation and virtualization. One more thing is continuous integration and automation from day one, even if you have no code. Okay? But bring your stakeholders together, agree on how the process will look like eventually to integrate. And then, last but not least, continuous homologation utilizing virtual testing. So, for entertainment's sake, Robert from Synopsys, where are you? Let's talk a little about virtualization. So, I know this is a big vision, okay, but the idea is that at the end of the day, we want to have the entire car in the cloud. We want all of our ECUs, we want all of our bus systems, we want everything in the cloud for development purposes, okay? Of course, we need to have different types of virtual bus systems. We need to solve the problem of all the subsystems running on the same clock and so on. And we need to have virtual ECUs on level 4, level 5, and so on. Okay, we're not there yet, but if we can get there, then we can have a virtual vehicle in the cloud. And with a virtual vehicle in the cloud, I can do amazing stuff like cut copy, paste. Yeah? Every Windows user knows this. So instead of taking a 500 square meter hill data center, right, and paying 10 million to replicate the data center for testing, left drive vehicle versus right drive vehicle, you wouldn't do that, but you get the picture, right? We can now go in and say, hey, Gen AI to the rescue. Tell me, what do I need to do to turn this from a left-hand drive into a right-hand drive? And then actually create a clone, and then have 2 test environments, one for the left-hand drive, one for the right-hand drive. Okay? As an industry, we're not there yet, but this is where we have to go in order to get this complexity and integration cost into order. And of course, we need staging then between these different environments, between the early virtual test environments to the hill environments down to the test fleets and so on. So coming back to digital first, it's all about shift north, shift left, divide and conquer. And if we have this, then we can achieve this beautiful picture of software being updated hourly, using automation to basically deliver software updates, at least test them, maybe not roll them out, but at least test them functionally, updated on an hourly basis, changes to the EE architecture maybe within weeks, and everything that's physical will still take months to change, right? And this we can only have if we have loose coupling and if we have these shift-left strategies in there. If we have this, then I think we have a lot of potential benefits, early customer feedback, closing this gap between requirements that nobody reads and not being able to match them to an implementation. Again, I'm exaggerating, but it is a problem. And then also, of course, much more flexible build-up of test systems in a virtual world, and so on. So this is what we're doing at the Digital Auto Initiative that Bosch and some other partners co-initiated, together with a lot of other partners. If this is of interest to you, do contact me. And with this, I would like to thank you.
Thank you very much, Professor Dr. Slama. Are there any questions around?
Yeah, thank you for this, and I fully agree. I would like to contact you later because we showed such a model that you talked about that should be there already in 2017 when we presented the Cherry CTX project on the System Engineering Day in Paderborn. And we are far ahead of this, so this would be interesting for you to have a complete, we call it product reference model of the EE system, including all its parts, hardware, software, and also communication in a graphical model.
Thank you. That was more a statement than a question though, right? Or, okay, good. I'm glad I got it.
I was surprised about the fact that we target virtual homologation. Is German official authority also a stakeholder of this decision?
So I think what's super good question. We actually published as Digital Auto a white paper 2 weeks ago on continuous homologation. So we have a working group in Digital Auto where we have not only Bosch and ETAS, but also, for example, TÜV Rheinland, and some other partners, T-Systems, Certivity, and so on. What we can observe is that the leaders who are now basically updating vehicles on a weekly basis, they have completely changed the way how they are working with the authorities. They have, the old way is, I get the type approval, bunch of documents, and then I never talk to the authorities again for 3 years until I do the next facelift. And the leaders have really changed the way how they work with the authorities. They have developed completely different relationships, and also different systems. So this is a huge topic. I'm not insisting that virtual testing will give you everything you need to get a full approval, but it's the first step in the right direction. But it starts with really change of the way of we think about it, the processes and relationships between the different stakeholders, including the KBA and so on. Oh, I can't speak for any of them. Yeah? I can only say that I think it is important that we move in this direction.